Did you send it? Huh? Zaid?
Yes, send it.
अच्छा, okay. So, the given temperature osmotic pressure of a concentrated solution of substance is ठीक है pi is pi is directly proportional. Zaid,
Yes, sir.
the first question is not right.
Don't know. Let me check.
What is the first question? See,
It's at a given temperature, osmotic pressure or concentration solution of substance is lower than that of dilute solution iodine.
so see if the concentration is
I
high,
was
the
confused in A and B, so
no,
maybe.
just need to write the equation of what is pi. Pi is equal to CRT, right?
Yeah, yeah.
If concentration is high, then the osmotic pressure will be
Hello. Higher, higher, higher. Directly proportional. Okay.
ठीक है मार्क्स से ये तो वैसे the next one is right. अच्छा ये तो नोट से ही था आपका. Which of the following will have the highest melting point? So this dichlorobenzene, 1,3-dichlorobenzene, 1,4-dichlorobenzene. Oh, here highest melting point. 1,4 is right. 1,4 is right because it is not having branching. It is almost like what is this? 1,4. 1,4-dichloro. Oh, 1,4-dichlorobenzene. Melting points. Okay, fine. Okay, I was thinking it was something else. One para substitute, na? Correct. Due to symmetry, right. Major propene with phenyl, 3-phenyl propene with H bear in the presence of 3-phenyl propene. Yeah, you have made the structure correct. And it will be 3-phenyl, 1 peroxide. Correct, very good. Then what do we have? Which reagents are required? One-step conversion of chlorobenzene. Chlorobenzene. Correct, very good. Wurtzfeld reaction. Which of the following is halogen exchange reaction? Addition of hydrogen electroalkene. Okay. A option will be correct, na? Here, halogen is replaced by.
Yes.
Colligative properties are observed when non-volatile solute is dissolved in volatile liquid. ये नहीं क्या 7th वाला आपने?
जी correct है. I have done like B1 is correct.
A1 is correct, na? Non-volatile solid.
Actually मैम told like A and B में confusion है. तो मैम अगर इस क्वेश्चन में गलत भी होगा तो मैं मार्क्स दे दूँ.
I mean, B is not even a right sentence because a liquid will always be some type. There will be volatility in liquid. It will get vaporized.
Yes.
Out of chlorobenzene and cyclohexyl chloride, which one of these more react towards nucleophilic reaction? Why? Cyclohexyl chloride will be more because chlorobenzene में आपका carbon halogen bond is having double bond character. Okay, the freezing point. ठीक है, this is so ये depression freezing point कर लिया होगा आपने.
ये क्वेश्चन मैम ने पहले से करवा रखा है तो सेम आंसर लिख दिया.
अच्छा, autosuggestion more reactive towards SN1. So SN1 में
ये
तो we
सारे
will have.
क्वेश्चंस वैसे ही मैम ने पहले से करवा रखे थे, मतलब एग्जाम के एक दिन पहले ही सारे क्वेश्चन करवा रखे थे, तो वही सेम
Oh,
पेपर आए, ऐसे ही समझ।
oh, no point discussing, I think. अच्छा.
यस।
Okay, fine. So you were not present in a few lectures, right? So we have
या
done till anti-Markovnikov's rule, and now
ओके।
let us write. Okay, wait a second. Let me just see whether I. And then the girls who were present here, they did not had a very good background in organic chemistry, so I taught them some basics of organic chemistry, like the naming and then how to write the bond line structures and so on. And I just want to see whether we have done. We started with from alkenes, hydrogen halide, and in the presence of peroxide, in the absence of peroxide. Okay, both are done. We have not done halogenation. So in alkenes only, we have the second type of reactions. Halogenation of alkenes. Now in halogenation of alkenes, what happened is, first of all, what we have to do when, please write this, when halogens are treated with, when alkenes are treated with halogens, they form vicinal dihalide. Okay, that means if I have carbon, double bond carbon, and there are two bonds attached to it, because alkenes will have two bonds attached to it, and I'm adding, let us say, Br2, then you will be getting carbon. These bonds will be as it is, there will be no change in those bonds, and you will get a Br in this carbon and also a Br in this carbon. Now, since Br are attached on the neighbors, hence we say that these are vicinal, and vicinal means in vicinity. Vicinity means in neighborhood. Okay, vicinity means in neighborhood. Also, write one more point. This is also used as a test for multiple bond in hydrocarbon. Hydrocarbon. Br2 is brownish red, or rather it is reddish brown. Better word is reddish brown.
So in the halogenation process, when we are Br2, can we add CCl4 here? We can add
No,
CCl4.
we don't add CCl4.
Okay.
CCl4 is just
That
is
is
the
the reagent.
solvent.
Sorry.
No, it's not a reagent, so it will react. No, CCl4 is solvent. Okay. Why do we use CCl4 and not water? See, Br2 is going to be non-polar. Okay. And if it is going to be non-polar, then we need a non-polar solvent also. And when there is things which are polar, we need polar solvents. Now, both alkenes and the substrate and the reagent, both of these are non-polar. That is why we use CCl4. It is not a reagent. Okay.
Okay.
Br2 is reddish brown, and on reacting with alkene, it forms haloalkane, which is colorless. So here you start with color and you react. So for example, you have some A component. There is some compound A, and you have Br2. Br2 is reddish brown. Okay. And then what happens? If this A is having any multiple bond, if there is a double bond or a triple bond here, then what is going to happen? It will get converted into haloalkane, and this haloalkane is colorless. That means if it goes from brown to no color, that means this A, it had double bond or triple bond, multiple bond. This is a test for multiple bond. Okay. So this is one of the chemical properties of alkene. The same reaction is there in 11th standard also.
Yes.
Same reaction is there also for Markovnikov, anti-Markovnikov rules. These are also there in 11th standard only on the chemical properties of alkene. So there are very similar reactions in this class and in the 11th class. Done? Yes or no? Please tell me.
Yes.
Now, write a very important question. Write a few questions. So let us say if I have something like this PR2, then it is going to give me now both of these the pi bond will break and both the carbons that had pi bond, they will get the Br, they will get the Br. But if you have something like this, let us say plus Br2, here also what will happen? This particular pi bond will break. First of all, you have to break the bond and then you will draw Br and then Br. Okay. Now, if I have the same molecule, the same substrate,
CH3 is added.
plus Br2, that is also same, but we do this in light, the presence of H2. Now this H2 will, what it will do, it will make free radicals, and now it will be doing free radical halogenation of alkanes. Now these carbons are what? Having the character of alkane. These, all of these three carbons are carbon atom. Now I can see that this carbon atom and this carbon atom are same because they are just one bond away from a double bond. They are just one bond away from double bond, and this blue carbon is what? It is a different carbon. Now, whenever we have free radical halogenation, we get a carbon free radical. Now, carbon free radical, which is having an entity, which is A double bond B, single bond C, and then there is a then there is a free radical. Now, this is going to show resonance, and that is why you will get a product which is like this. All the pi bonds will be there like this, and you will get a Br here on top. Because this red free radical, it will be very stable. Or the same thing will also be there if you will draw it like this. Both of these are same molecules. Both of these are same molecules. Okay. So you have to take care of this. Whenever you see H nu and there's a double bond, you look for resonance. So there always will be resonance. So even if I have something like this, let us say. Okay. Plus Br2 H nu. Now there are two radicals which can be present, A double bond B, single bond C, a radical here or a radical here. Now, obviously, this radical is going to be more stable because it is having more groups. Okay, it is also having resonance and it is also having inductive effect. That is why we will write the major product will be the pi bond will be as it is. There will be no change in the pi bond, but here you will get a Br. Okay, now these are not the reactions of alkene. These are what? Free radical. Halogenation. Okay, please write this down. All of these reactions. Let me know when you are done.
So finished. Yes.
Right. Sandmeyer reaction. No, in Sandmeyer reaction, please write. When benzene diazonium salt is treated with when benzene diazonium salt is treated with cuprous chlorine or cuprous bromine, then it forms What will it form? It will form either chlorobenzene, uh, chlorobenzene or bromobenzene.
So some books it is written like Cu2Br2. Some books it is written CuBr. Why it is so?
Cu2Br2. It is equivalent to CuBr only, no? Because
Yes.
we can see the same thing. Actually, the formula is Cu2Br2, but we write it as CuBr. I mean, CuBr, it has a property of dimerizing. So whenever you have CuBr, it is formula because. But if you look at the molecule, then you will always see that molecule is having two copper and then two bromine atoms also. So they have a tendency to dimerize. That is why you will see some books are writing Cu2 and some books are writing CuBr only. Okay. Similar is the case for Cu2Cl2 also. Now, here what happens? We have benzene disonium salt, which is benzene disonium chloride or bromide. So you have this thing. N2 will be positive and Cl negative. When this reacts with Q plus chloride, then what happens? It will give you chlorobenzene. And if I have something like this, same molecule, N2 positive, Cl negative, plus, sorry, Cu2Br2, then it is going to give me Br. Okay. Now, please write a note. Benzene disonium salt or benzene disonium chloride, BDC. BDS or BDC. Benzene disonium chloride is freshly prepared by treatment of ammonia with sodium nitrate and HCl. So here we have ammonia plus NaNO2 plus HCl is going to give me benzene disonium chloride.
So will we get nitric acid from here? Nitric acid मिलेगा हमें यहाँ से?
You don't need nitric acid in the reaction. You just remember this much. Okay. See, whenever the byproducts are required now, for example, in this in this whole chapter, the thionyl chloride is one of the examples, one of the questions in which you need to remember what is the byproduct. Okay.
Yes.
Otherwise, you don't need, and please don't remember also what is the byproduct. Never use. You will be always asked to write the major product. No one is caring about byproduct until unless they care about it. That means whenever they care, they will tell you. No, please remember the byproduct. Okay.
Yes.
Here you will having N2 will be there and N2 plus and Cl negative. Please write this down. Let me know when you're done. Done? Okay. So one of the questions that they generally ask is in conversions. Let's write it like this. What reagents would you use for following conversion? So the conversion that they want you to remember and learn is how will you convert ammonia to chlorobenzene. The first step is to convert it to benzene diazonium chloride. That means you have to add NaNO2
In the presence of
plus
HCl.
HCl. Second step is
Then
Cu.
CO2.
Achha, none of the conversions were asked in your test, I think, or did they ask
Yeah, in the D section they asked.
these sections? Oh, so similar reaction. Aniline to bromobenzene, you just need to add CO to Br2,
Yes.
right? And ethane all to propane nitrile. This is a and 1 into fluoropropane. So first of all, here you have to do add some kind of Br se ho jayega, and then you need to do the halogen exchange reaction. That is it. Okay. Simple much. And in propane and ethanol to propane nitrile, first of all, you will react this with, let us say, NaOH or KOH. You will get, sorry, you'll react this with NaBr or KBr or SOCl2 will be a good ethanol plus SOCl2. It will give you chloroethane. And after that, we just need to react this with KCN. It will give me propane nitrate. Okay, you have to just
So here we cannot we cannot react AgCN here. It will form NC.
No, NC, right? Correct. KCN, that is I am saying. You can only react with KCN. KCN is very important reaction because in that case, what is happening? You see, you are going from 2 carbons, right? To 3 carbons, right? And that is more important. This is important reaction. That's it. 3 carbons will be like this. So 1, 2, 3 carbons are here. So carbon-carbon bond formation is happening in KCN, and that is one of the very important reaction, carbon-carbon bond formation. So is everything done? Yes or no, please tell me.
Yes.
All right, the E part, that is halogen exchange methods. Oh, there is one more reaction. Is right here for the preparation of iodobenzene, benzene diazonium chloride, or benzene diazonium salt is just stirred with K. So you have now when you're stirring it, you're adding some kind of heat. So you may also see heat and Ki, and you're going to get it. Please write this down. Then write.
So when I was doing this reaction, I did only Ki. I didn't use heat. So it is necessary
Not
to.
a problem. No.
Right?
It is stirred, right? So stirring is giving heat like this. So I'm saying that you may see this type of reaction. Okay, where some they have given heat. But it's not a problem.
Yeah.
Last one is halogen, but this is not Sandmeyer.
Yes.
This is not Sandmeyer. Halogen exchange methods. Done, yes or no, please tell me.
Yes.
Right, next. In halogen exchange, number 1 is Finkelstein reaction. This is the second name reaction, okay? Finkelstein reaction. What happens in Finkelstein reaction? Please write. When chloro or bromo alkanes are treated with sodium iodide in the presence of dry acetone. So acetone is a liquid. Then how can it be dry? Can you think? Tell me, Zan. Acetone is a liquid. How can it be dry?
So actually, it is like we studied like everywhere we use acetone, it is dry on.
But why? Like, but acetone is a liquid.
Yeah.
So how can it be dry? What do you think?
Maybe NaI will be soluble. No, no, no.
No, no, no. Why it is? How can it? How can a liquid be dry? I'm asking that. Na?
Liquid beta.
So,
No, I don't know.
how can a liquid? So dry means without water. Okay.
Ah, okay.
So dry has a meaning. Dry means if you don't have any water content, that means it is dry. So whenever you hear this word, na, dry, then please don't think that it will not get you wet. It can get you wet, but it is going to be not water. It is not going to be water. And also acetone, it vaporizes very easily. Okay, it leads to the formation of iodoalkane. So you can write some reaction like this. So, right, next, second one is Schwarz reaction. Schwarz reaction. Is there anything? When alkyl chlorides and bromides react with metallic fluoride, they form what? They will form what they will form? Alkyl chlorides or fluoroalkane? Alkyl
Yes.
chlorides. So we have something like this. Okay, so the metallic fluoride, we give an arrow like this. Okay, what is going to happen? I will get, instead of Br, there will be fluorine. Oops, sorry. This will be either chlorine or bromine. Sorry. Please write this down. Let me know when you're done.
So finished.
Okay. So what are the method of preparation that we have done till now? See.
So we have done a halogen exchange, Sandmeyers from alkenes. We have done addition of halogen. We have
Before
done
that,
from alcohols, from hydrocarbons. That is, I'm sorry, free radical halogenation. One left, so by electrophilic substitution.
electrophilic aromatic substitution, that is not done.
Maybe.
Electrophilic aromatic substitution, I think also, yeah. I think electrophilic aromatic substitution is not done. Let us write the last one. Electrophilic aromatic substitution. So the E part by electrophilic aromatic substitution. Now what happens in electrophilic? Now I will just write some reactions. You can easily make the products, right?
Yes.
I'll have Cl2 in the presence of AlCl3. What's going to be the product? If I have, let's say, Br2, the presence of FeBr3 or just Fe also, then what is the product that I'm going to get? Further on, two more important examples will be if I have a, let us say, following. That means I have a CS3 group here and I add Br2 in the presence of Fe or FeBr3. Then I will be getting two products. I will be getting a parallel product and I will be getting a ortho product. I'll have CS3 like this. And there will be a Br here. Plus I will get CS3 and Br here. But if I have groups such as NO2 plus, let's say, Cl here, you have the presence of AlCl3. Then here what I will be going to getting, I will be going to get not an ortho or para substituted product, rather only a meta substituted product, right? So it will be something
Yes.
like this. I can just move the B somewhere else. So meta will have one carbon in between. So Cl. Any problem till here now?
No.
Okay. So for the above reactions, I hope you have written like this. Benzene ring with a chlorine, followed by benzene ring with a bromine. Okay. Now, moving on. Now let us just revise the method of preparations. So in method of preparation, we have done what? We have done, first of all, with, let us say, hydrocarbons. In hydrocarbons, we have done with alkane. In alkane, there was only one, that is free radical halogenation of alkene. Then we moved on to alkene. In alkene, we have one part which is halogenation. Okay, in that we are just using Ca2Br2 without any reagent. Then we have in alkenes, we have one more, which is when we are using hydrogen halide, that means we are using HX. Now, whenever we are using HX, then what we can see that there are two cases. When you have peroxide, okay, or heat, then what is going to happen? You are going to get anti-Markovnikov product, right? You are going to get anti-Markovnikov product, and if there is no peroxide or light, then you are going to get a Markovnikov product. Clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now, after the alkene halogenation, we saw that what we can do one more, which is, okay, we have seen halogenation and hydrogen both. Okay. Now, after alkenes, what did we do? Let us say that we did alcohols. And alcohols, the important thing is SOCl2. Okay. And then what did we do? We did halogen exchange methods. Here we have Finkelstein and here we have Schwarz reaction.
Yes.
At the end, we did EAS. And here you have to remember that the electron donating group, it will give you ortho and para product, and electron withdrawing groups, it is going to give you meta product. Is that clear? Yes or no? Please tell me.
Yes, sir.
Did you write this all? Tell me yes or no?
Yes, sir. That.
Now, one thing you have to do before the next class, that is on Sunday, tomorrow, you have to make a chart something like this. Okay. So just imagine that this is my complete page. Okay. This is my complete page.
Okay.
And in the middle, what you will write? In the middle, you will write like this. Halogen. Halogen name, you will write haloalkane.
So like flowchart?
Yeah.
Okay, got it. Like arrow diagrams.
Arrow diagrams.
Okay.
Haloalkane. Okay. Then here you will write it like this, alcohols. Now in alcohols, whatever reagents you have been using, you will list out all the reagents. Then what you will see, you will roll.
Sir, I have made this one. I think, yeah.
Made.
I made this one.
But also then see, this should be one chart, and then when we have done with the chemical properties, then you will draw it like this. Start with haloalkane, and then if I'm reacting this NaOH or KOH, that is in aqueous state, then I'm going to get what? Alcohol.
Yeah.
Alcohols, right? So this kind of diagram you have to make. Okay. Now this will help you in conversions very much, because if you want to start with alkene and then end up at alcohol, then you that the route is through haloalkane, right? So these type of reactions are very important in this chapter and the upcoming chapters also. Is that clear? Yes or no, please?
Yes.
So now we are done with all of the method of preparation, correct? Yes or no?
Yes.
Do you have any doubt? Tell me.
No, sir.
No? Okay. So can we do some problems?
Okay, sir.
Let's see. Write a question. How will you bring about following conversions? To the first one, propene to 1-fluoro propane.
So peroxide we have to use here 1-fluoro. Okay.
To draw the whole thing, then send me on WhatsApp.
Okay, sir.
Zad, let me know when you get stuck, okay?
So finished. Just sending.
Okay, okay.
Okay, sir.
Write this one there. Very good on the first one. Do the second one and tell, send me the answer. Okay, sir. Zad, let me know if you are stuck, okay? Okay, you have sent the answer. Let me see. So butanol to 1 iodobutane. Okay, fine. HI. And then 1 chlorobutane to 1 iodobutane. Okay, very good. And then we have 1 butene.
So
One.
I'm having confusion in this one but one in. I've done
Tell me.
before, but is it correct or not? Just
It is
wanted to
fine.
know.
HBr, you have peroxide, then it will be 1
Mhm.
bromobutane, and then 1 iodobutane. You just need to NaI and triacetone. That is it, correct. Very good.
So should I do the next question?
Next question. Please do the next one. And then send it.
I know this answer. This is that a chloropentane, I think. Chloropentane.
Saurabh,
Yeah, yeah. I have done this in worksheet. So okay, great.
this is not chloropentane. You try doing it once again. Zad, you have to identify what is this molecule, C5H10.
Yes, I have seen this answer, but it was very long and it was like talking about first we have to like
Did you
prove that
understand that?
yeah, what structure it
Huh?
is.
You have to identify the structure. So the
Mm.
first thing, whenever you get a structure, is what do you do? The first thing, tell me.
First we check is it first we see the formula of the structure
Yeah.
that
Okay. Formula is given.
yeah,
So we have C5H10.
yes.
Then it is given, and after that,
Mhm. Then we check it belongs to the cyclohexane
no. So yeah,
cyclohexane
correct. That means this
can
formula can either be alkane
yes
or alkene, right?
yeah,
Or
yeah,
it can be
that is the
cycloalkene. There are
yeah
many classes, right? So we can
yeah
directly say that it cannot be alkane because alkane has
mm,
CnH12. Now it can be either alkene because alkene has CnH2n formula, and
yeah
cycloalkane also have the same formula. Okay, so it can be either alkene or it can be cycloalkane. Now, what we will do next? Tell me.
uh, next we will try to make the structure I think so.
So for alkene, we can get a few structures from alkene. The first structure that we can get is uh, so we have 5 carbons and 1 carbon will have a double bond here, or another structure could be something like this, and another so we can only have 2 structures, I think, right? Yeah, we can
Yes.
only have 2 structures. So these can be the 2 structures from alkene, and the only structure from cycloalkene can be of
Mm,
cyclopentane,
mm,
right? Now, how now we have three. We have boiled it down to 3 structures. Now, what we can do?
mm. Now we can do reaction with the as they have told it reacts with the what is it? It reacts with chlorine and it does not react with chlorine dark, but it reacts with chlorine in bright light and forms
Hmm,
C5H9Cl.
hmm. Very
So we
good.
will try to make we will try to do that reaction now.
Hmm. So the first thing is that they are saying that it does
Mm,
not react with chlorine in dark. है ना?
mm,
So it does not react with chlorine in dark. We will say that C5H10 cannot be alkene, cannot be alkene, as alkenes they react with they react with they, or rather I should say they will react with halogen, or you can they react with X2 and form vicinal dihalide. Okay. Now, if it cannot be alkene, the only probability is cycloalkene, and then you will show the reaction that
Yes.
if you have cycloalkene like this, and we do Cl2, the presence of H nu, then it is
Yes.
going to give me only one monochloro product, that is going to be
Yes.
one chlorocyclopentane. Okay.
Then we have to show like it does not form any reaction with dark in the dark. So we can make another arrow. We can show dark.
What we can do?
We can show another arrow and we can like add Cl2 and we can show like no reaction is formed.
Okay, fine. Yeah, but so you are saying that we can. Wait a second. We can do something like this, that if I have these two things, then Cl2 in dark, so give no reaction. But it is alkene, if you react with Cl2, it will give reaction, right?
Yeah.
Yes or no? Anna. So better is that you write this statement C5H10. Anna, you now when you have made this flowchart, the teacher is understanding that C5H10 can either be alkene or it can be cycloalkene, right? Then you have drawn the possible structure for alkene. Then you have said that since they have said that it is not reacting with chlorine in dark, that means it is not going to be alkene, because alkenes they react with chlorine in dark, right? They
Yes.
react with chlorine in dark and they form vicinal dihalide. Then you will say C5H10 cannot be alkene. Why? Because alkene they react with H2 in dark, in dark, and form vicinal dihalide. Now the only option that is left is of cyclopentane. So you will say that cyclopentane is our hydrocarbon. Got it? Yes or no, please tell me.
Yes, of course.
Okay. Fine.
So finished.
Finished now? Okay. I'm just seeing if there is any other. This is a similar question, but the name is a bit different. That's why so how will you convert but1e to N butyl iodide, normal butyl iodide?
So same procedure can be followed like let me make it simple.
In the before we have a similar question, right? It is
Yes.
iodobutane and but1e, right? So it is the same question here. Correct. You have identified it very correctly. Okay. Now, after this, what we are going to study? We are going to study the physical properties of haloalkenes and haloarenes. Okay, physical properties of haloalkenes and haloarenes. Now, in physical properties, mainly you will learn about three things. Those three things are what? Those three things are, first of all, we'll learn about the boiling point, melting point, and solubility. In all of the organic chemistry chapters, you start with general classification, IUPAC nomenclature, the general things about that. Then we move on to the first thing that we learn about, which is having some type of chemical importance, is the method of preparation. After method of preparation, we are going to always learn about the physical properties. Okay. And the third thing that we are going to learn about is the chemical reaction or the chemical properties. Okay. Physical property and then the chemical property, starting with IUPAC nomenclature, then method of preparation that we have already done. And then we are now moving on to what? The physical property. Okay. Please write with me. Physical properties of haloalkane and haloarene. Physical properties haloalkane and haloarene. Now, and what did I say in physical properties? What are we going to
So
study?
first we check like the state of the matter, sorry, the state of the substance.
State
Then
of a substance.
then we check whether it is polar or not. What is like bonding between it? If it is polar, then we check uh,
See,
boiling point.
we'll make it simple. See, you will never get a question asking about what is the physical state of haloalkanes, right? So
Yes,
what we will study? We will study boiling point and melting point. What we'll study?
boiling point. Milk.
Boiling point and melting point. Okay. So now what you can tell me about the now whenever we are learning about boiling point and melting point, intermolecular forces of attraction, they will come into the place, right? So let us write the topic: boiling point and melting point. Okay. Now, first thing is that we can say that organic halogen compounds or the haloalkanes that we have, they are generally polar, right? They are generally polar because we have a CH bond due to the CX bond. We will write delta negative and delta positive with the C. Due to the CX bond, halogen containing compounds are generally polar. They are what? They are generally polar. Now, due to polarity and and the higher molecular mass. So as we go down the group, what will happen? The mass of halogen atom will increase. The mass of halogen atom will increase, and then what we can say that we can say that their molar mass is greater than the corresponding hydrocarbon. For example, if I see CH4 and if I see CH3 fluorine, so CH3 fluorine's parent hydrocarbon is CH4. Now the molar mass is also greater here, and also the intermolecular force of attraction due to polarity. Due to polarity and higher intermolecular force of attraction, well, higher molar mass. Intermolecular force of attraction is already there in polarity. Due to polarity and higher molar mass, molecular mass, haloalkanes haloalkanes have higher due to higher molar mass and have higher intermolecular force of attraction as compared to their parent
Parent
hydrocarbons. Their parent hydrocarbons. So we can write next point, boiling point. Rx will have higher boiling point than RH. This is halogen, this is haloalkane, and this is going to be a just simple alkane. Now, important point for a given X atom. That means what we are having for a given X atom. That means if we are what doing, if we are just comparing the number of carbon atoms and we are keeping the halogen atoms same. In that case, what we can say, in this case, the boiling point is directly proportional to number of carbon atoms. Okay, because the molar mass is increasing. Because what's happening? Molar mass is increasing. Now, if I keep the alkyl group same for a given R group, that means we are just comparing, let's say, methyl fluoride, methyl bromide, methyl chloride, methyl iodide. We are comparing ethyl fluoride, ethyl chloride, ethyl bromide, ethyl. So what is changing here? Only the halogen atom is changing. Only what is changing? Yeah, halogen atom is changing. And here what will be happening? Boiling point will be directly proportional to molar mass of what? Molar mass of the X atom. Okay. So in this case, we can write Ri is going to be your having highest boiling point followed by
then RBR,
RBR,
R,
RBR, RCl, Ri. Okay. Now the next point is it is going to be true in every case that boiling point will be indirectly proportional to branching.
So because when branching increases, so then surface area decreases. Yes.
Surface area decreases, and what happens? The probability of electron distortion is getting lower and lower whenever the surface area increases. Okay.
Yes.
So you can write BP for 1, 2, 3, 4. Your BR. This will be having highest, lowest, and then if you have this, okay. So that is it for today. In the next class, we will do the melting point. Okay. In the next class, we'll do the melting point. And important question of, I think you already know that the important thing is that the para isomers, they have a higher melting point due to symmetry, right? So we'll discuss that in next class. That is on symmetry. Okay.
Yes, sir.
Okay. Chalo. You have written this down, yes or no? Tell me.
Yes, yes. Finished.
Finished? Okay,
Yes, yes.
okay. Also, Zad, tomorrow you will have a test on haloalkanes. Okay. Method of
Okay,
preparations. Okay. Sure. Thank you. Bye bye.
thank you,
Take
sir.
care. Thank you.
Bye. Islam.